Good morning, everyone. Myself Devika, working as assistant professor from the Department of Electrical and Electronics Engineering at Sri Muthukumaran Institute of Technology. Now I am going to present a subject on Control Systems Engineering MR3452 at 2021 regulation, which is a subject for Mechatronics and Robotics Engineering, fourth semester. Now we are going to see a topic, block diagram. Block diagram. It is a graphical representation of a control system. It is used to model both simple and complex systems. It consists of blocks, summing points, and takeoff points connected together. Each block represents a component or a subsystem. And the diagram helps us understand how the system works and how signals flow from input to output. Need for block diagram reduction. It is required because practical systems contain many blocks, which makes analysis difficult. And for easy understanding, we reduce multiple blocks into a single equivalent block. Then a reduction is necessary to calculate the overall transfer function of the system. So block diagram reduction simplifies complex systems. Block diagram reduction techniques. There are several techniques used for block diagram reduction. I will now explain the important ones briefly. Number one, combining blocks in cascade. When blocks are connected in series, they are called cascade blocks. The overall transfer function is obtained by multiplying individual transfer functions. For example, if blocks are G1 and G2, overall transfer function is equal to G1 into G2. Next one, combining blocks in parallel. When blocks are connected in parallel, the overall transfer function is obtained by adding or subtracting the blocks based on the summing junction sign. So overall transfer function is equal to G1 plus G2 or otherwise G1 minus G2. Third point, moving a summing point behind a block. While moving, we must multiply or divide by the block transfer function to maintain system equivalence. Moving a summing point ahead a block means we must multiply or divide by the block transfer function to maintain system equivalence. Then moving a pick off or a take off point or branch away point behind a block or ahead a block. Again, while moving, the signal must be adjusted properly to keep the system unchanged. Then, next, eliminating a feedback loop. Feedback loops increase system complexity. A simple feedback loop can be eliminated using the formula. Here, we have two feedbacks, negative feedback or a positive feedback. So overall transfer function of this eliminating feedback loop means open loop is denoted as G, closed loop, feedback is denoted as H. So overall transfer function is equal to G divided by 1 plus or minus GH. For negative feedback means 1 plus GH. For positive feedback means 1 minus GH. Next, swapping with two adjacent summing point. So there is no changes in this problem. Next, let us now see an example to understand block diagram reduction clearly. Here, find the transfer function of the following block diagram. So we know that input of the system is denoted as R of S and the output of the system is denoted as Y of S. Here we know that in block diagram we have the three blocks. We have three elements: summing point, blocks, takeoff or branch away points. In this problem, step in step 1, we have solved move the pick-off point ahead of the block. So the branch of point is ahead of the block means here we have two blocks are cascade and then parallel. So we have to reduction technique reduction reduced by using the reduction techniques. So we have to reduce G4 plus G2, G3. We know that two blocks or cascade means we have to multiply, and then parallel means addition or subtraction. Then moving pick of point B behind the block. So we have to reduce G4 plus G2, G3. Then we have using eliminate loop for here we have negative feedback loop. So G divided by 1 plus GH. By using this block diagram reduction techniques, we have to solve the transfer function of the system. So overall transfer function of the system T of S equal to Y of S divided by R of S equal to G1 into G4 plus G2 G3 divided by 1 plus G1 G2 H1 plus H2 into G4 plus G2 G3 plus G1 into G4 plus G2 G3. This is the overall transfer function of the system. To conclude, block diagrams help in system modeling and reduction simplifies complex systems. It helps in finding the overall transfer function. These techniques are very important in control system analysis. Thank you.